Hey there, 6th grade. This is our last video in our unit over plane figures, and in this video we're going to talk about something called symmetry. Many architects and artists use symmetry when they do designs for buildings or they create their artwork because symmetry by nature is very pleasing to the eye. In this video, we're going to look at two different kinds of symmetry. The first kind of symmetry is what's called line symmetry. Line symmetry occurs when you can draw a line through a plane figure so that the two halves are mirror images of each other. And when that happens, we say that the two halves are symmetrical. The line along which the figure is divided is what we call the line of symmetry. When a figure is not symmetrical, then it has asymmetry, or we will call it asymmetrical. So let's look at examples 1 and 2, and we're going to decide whether each figure has line symmetry. If it does, then we're going to draw all the different lines of symmetry. So in number 1, we have a triangle. It appears to be an equilateral triangle. And we're going to try to determine whether or not it has line symmetry. Well, let's imagine drawing a line from this vertex at the top down the middle of the triangle. If you were to fold one half of the triangle over on the other, would you get the same shape? And the answer is yes. Okay, so the left half is a mirror image of the right half, and therefore we have line symmetry along this line here. We could do the same thing by drawing a line from this vertex, the left vertex, down the middle. There's also symmetry along that line of symmetry, and there's also symmetry along a third line of symmetry, the line from this third vertex down the middle. So not only is this triangle symmetrical, but it's symmetrical along 3 different lines of symmetry. Okay, number 2, we have an octagon in sort of a ninja star shape, if you will, and we're going to ask ourselves whether or not this figure has symmetry. Sometimes it takes turning your paper, rotating your paper to see whether or not a figure has symmetry. But yes, this one does. There's actually a few different lines of symmetry we could draw. I could draw a line straight down the middle. And you could see if I folded the left side over the right, they would be mirror images of each other. So this is one type of symmetry. I could draw a line across through the middle. And if I were to fold the top piece over the bottom piece, again, they would be mirror images of each other. So there's a second line of symmetry. I could draw a third line of symmetry from this top left vertex through the center and then through the bottom right vertex. So that this piece folds over the upper right piece, and then I could draw a fourth line of symmetry from the bottom left vertex through the center through the top right vertex. So there's actually 4 lines of symmetry that we could draw in that figure, and so yes, it is symmetrical. Okay, we're going to do the same thing now in examples 3 and 4. This time we have 2 different flags, and we're going to find all of the different lines of symmetry we could draw for those. Number 3, this is the flag of France, and I want you to take a moment and see if you can find any lines of symmetry in this figure. Okay, can you draw any type of line so that you would cut the figure into 2 equal halves? Okay, there is one line of symmetry in this figure, and it's actually the horizontal line that cuts the figure down the middle. So that would be this line here. Okay, if I were to take this flag and fold the top half over that line of symmetry, it would be exactly the same as the bottom half. You cannot cut this figure down the middle because if you cut it down the middle, you have one side that has a blue bar and then the other side has a red bar. So those would not be symmetrical to each other. Okay, and the same reason you cannot cut it diagonally. If you cut it diagonally and try to fold those pieces over each other, you have a red bar going over a blue bar. So there's only one line of symmetry. It's this horizontal line that puts blue over blue and red over red. Okay, and number 4, we have the American flag. And I want you to take a second and see if you can find any lines of symmetry there. Okay, for this one, there actually are no lines of symmetry. Okay, there's no way to draw a line so that you could fold one half over the other and get the same mirror image, just the way the American flag is set up. If I try to draw a horizontal line, then in the top half I have my blue box with my stars, and the bottom half I don't have that. If I try to draw a vertical line, I have the same issue. Okay, I have the blue box in one part and then no blue box in the other. So we would say that for the American flag, there are no lines of symmetry. Okay, look at the back side now. We just talked about line symmetry. Now we're going to talk about something called rotational symmetry. A figure has what's called rotational symmetry when if it is rotated less than 360 degrees around a central point, it coincides with itself. That central point is called the center of rotation. So if you look at the right figure here, this is a picture of a stained glass window. Imagine taking this figure and rotating it 90 degrees clockwise. If we rotated this figure 90 degrees clockwise, you can see that this left vertex would come up here, this vertex would go down here, etc., etc., and you would essentially get the same figure. And so that's what's known as rotational symmetry. When you can rotate a figure any amount less than 360 degrees and still get what appears to be the same figure. So what I'm going to do here in examples 5 and 6 is tell how many times each figure will show rotational symmetry within one full rotation. So basically, how many times can I rotate a figure to show the same image before I get back to the original? And so in number 5 here, I have a starfish. And so what I'm going to do is I'm going to sort of help you visualize this by drawing the center of this starfish and then extending its legs. I don't know what you call these ends on a starfish. I'm going to call them legs. I'm sure there's a scientific term for these. Extending those a little bit further. So there's one extension. There's another. There's a third. A fourth. And a fifth. And so now I want you to imagine what would happen to this starfish if I started rotating it clockwise. Well, if I rotated from this imaginary line down to this imaginary line, this piece would move down here. The next piece would move in this location. The next piece would move here. But you would really get the same picture. You would just have each leg in a different position, but it would be the same. It would look like the same starfish. And then I could rotate again from this imaginary line to this imaginary line, and I can do that a total of 5 times. So this starfish has rotational symmetry, and I can rotate it 5 times. Okay, finally in number 6, I have a picture of a snowflake. So I'm going to do the same thing. I'm going to draw the center of the snowflake and then extend some imaginary lines out. And so now I want you to ask yourself, how many times can you rotate this snowflake so that it appears the same as it does now? Well, I can rotate from this line to this line. Again, from here to here. So that's 2 rotations. Again, here to here is 3, 4, 5, and then 6. Okay, so this snowflake has rotational symmetry, and it's 6 times I can rotate before it gets back to its original position. Alright, if you had any questions over this video, make sure those are written down so that you will remember to ask those the next time you're in class. Until then, have a nice day. You're all wonderful people.